In this lecture video, we're going to learn what it means for a real-life set of data to be approximately normal. First, let's review what it means to be a parameter or a statistic. The difference is if we're talking about a sample or a population. If we're looking at a population, that means we're taking every single individual data value into account. We're not leaving anything or anyone out. A sample is a subset of a population that we often use to infer information about a population. We also have different notation when we're talking about a sample and a population. With a sample, we use the notation x bar for the mean and lowercase s for the standard deviation. For a population, we use the Greek letter mu for mean and sigma for standard deviation. The values that we find for a sample we call statistics, and values that refer to the entire population are called parameters. When looking at normal distributions and approximately normal distributions, we're going to want to look at the entire population, or at least very large samples. That's when we expect normality to show up. Consider this example set of data. We have 87 students that took a 10-point quiz. They could score any whole number from 0 to 10. And from this frequency table, we can see that no student scored a 0, 1, or a 2, while 2 students received a score of 3, 6 students received a score of 4, and so on. Notice that most students have scores that are clustered right around here. There are some students that scored less and some that scored more, but a majority are clustered close together. Let's look at the corresponding frequency bar graph for this data set. We can visually see that the majority of students are clustered in the middle, with a few to the left and a few to the right. We consider this data set to be approximately normal. The bar graph is approximately bell-shaped. Notice that if we draw a bell curve right over this bar graph, we can see that the bars approximately take on this shape, but not exactly. There are some important features. There's one peak, and the graph is approximately symmetrical. A lot of large real-life sets of data are approximately normal, and even though they're not perfectly normal, we can use the idealized normal distribution to get a lot of really useful information. If a distribution is perfectly normal, it will take on this exact shape. It could be shorter and wider or taller and more narrow, but it will have this perfect bell-shaped curve that's also perfectly symmetrical. And we can use properties of a perfectly normal distribution to get a lot of valuable information about our approximately normal distributions. And that's what we mean when we say that a data set is approximately normal.